Welcome back to the show, everybody. It's still snowing and I'm still waiting on my delivery to proceed with the flywheel machining. But in the meantime, we can do some busy work. It all has to be done. Let's start working on the mandrel for the new splined center hub that we are going to have to make for that flywheel. All right, so Senior got us pretty close on the mandrel. I would say we're within 20 thousandths of desired end size. My plan is we've got 2 set screw holes in the new hub piece. I want to utilize at least one of these set screws to locate this onto the mandrel. So that means I need to mill a flat spot in the mandrel so that the set screw can go down and have something really good to contact. That means we'll take the mandrel out since we're not finished with it yet. We'll cut the flat in it first, and then we'll throw it back in here, get it reset again, and then do our final passes, get it all to size, and at that point we can leave it. We don't have to take it out of the lathe anymore. So I've got it marked out about where I want to have my flat. This is not going to be a super critical type job, but machinist vise loaded on the table, and we'll pull an end mill out of here. I think I'm going to do it 3/8 because those set screws are 5/16. That'll work. With a good flat segment like that, it's going to be near impossible for that hub to twist on here once the set screw comes to rest on it. So you can throw it in for the final time. Locate our tailstock. Everybody that has a real lathe now is just probably shuddering looking at how you have to set this one up, but it works. I like it. All right, time for a test fit. We should be there. Perfect. It's still positionable by hand. No play, no click, no slack. So let's get it centered up over the flat that we made. Right there. And here's how we're going to lock it in place. Set screw will go down and engage with the flat part that we milled into the side. There. It's tightened up. That should hold it fast. There's no way that can spin on there now. Not the way we got it locked in place. So we are ready to machine here. And since we're still playing the waiting game, we can do a little bit of work to the flywheel. Mainly, how are we going to attach this to the milling machine table, clamp it, locate it, center it, so that we can accurately re-round this center hole, take all of that galling out of there, make sure we got everything in good condition. After we can figure that out, then dealing with these threaded holes later. should be pretty simple. So we'll dive into this. So 2 ways to do this. I've already looked at it for a bit, and the way I've done it before, I use these T-nuts, go down in these slots, and I can throw a 1/2-inch bolt down through. We've got 2 dowel pin holes right there and right there. I can throw a 1/2-inch bolt down through those, engage it with the T-nut, secure it to both sides, and this thing isn't going anywhere. The problem is, though, if I'm going to be working on this center bore, I have thrown a dial indicator on here, and as soon as I snug those 2 1/2-inch bolts, this whole center section will actually drop by about 2/1000ths of an inch. And if I'm going to try to do some rather precise milling in here, that's no good, because, well, yeah, we can tighten it down, drop it, mill what would be a true bore, but then as soon as we take those bolts out, it's going to rebound, and then everything is thrown off. So that means we can't position it face up like this. We're going to have to flip it and throw it in upside down. More like this. All right. We still have a nice flat milled face here that is face down on the table. We'll make sure that everything is flat, level, and plumb, but we're going to have to clamp this from the outside. And we are solid on the table. So the next thing we have to do is verify flatness, centering, all of that good stuff, but we're going to have to, once again, make a tool to accomplish that task. So, well, got some of this tight tolerance 5/8 drill rod. I think that will be our material that we will work with. We'll have to take one end of it down to, yep, 1/2. And the other end will have to be 0.470. And overall about, yeah, that long. Here's our tool. We are 1/2 inch on this end, and then we step down to 0.470 on the other end. So the 0.470 will take the place of this piece right here, so we can use the rest of the dial indicator stylus that fits the clamp well. Cinches down. All right. The 1/2 inch collet goes into the milling machine. And then we stick the 1/2 inch end of our special adapter into the milling machine. We can secure it with the drawbar up top. And now we can position dial indicators anywhere we need them to be. So the first thing we have to check is to make sure the flywheel is flat on the table. If we were to clamp this flywheel in, say, you know, canted to the side. This is an exaggeration, but this is how it would work. We would mill a hole that would be straight down, but then once we flatten the flywheel out, the hole is crooked. All right, so we've got the dial indicator centered. We are on the crankshaft mounting flange, so we've got a very true surface. And we'll just roll it around. We don't want to see that needle move at all. Now it's going to do a little bit of a drop just as we come along the edge of those bolt holes, but that's because the needle is just trying to drop down in. So we'll dive a little bit here. Yep, it's trying to drop into that hole. Now we're back to the flat. We've zeroed back out. We'll just keep slowly going all the way around. Make sure that we don't have any run out, any change showing on that needle. Still looking good. One more drop around the edge of that bolt hole. It returns right back to zero. We're flat. No deviation at all. Now we take this dial indicator off. We're finished with it. Comes out just like that. And we will put this one in its place. So we've got similar face, but this one has this little pivoting arm on the back so that whenever it comes up against an object, it will pivot and depress the plunger that's at the top. And the plunger is what registers the needle, all right? So it's kind of like building an erector set, but it works. Make sure we get our pivoting arm back behind the flange because we want to read around the vertical surface, full 360. I've got us zeroed up right here. We'll see how far off we are. I think we're close from the prior setting, but this is really going to tell the tale. So, yep, I can see the needle just starting to move right now. I know it's heading out of frame for you guys. Get you thrown up on the other side here. Yeah, we're 8 thousandths, 10 thousandths off, 12. Okay, and 12 is about where we top out. So what I'm going to do, roll this back around and we will shift the table and just take out half of that difference. All right. And of course I go the wrong direction first. Take that down to about 6. We'll crank it back around here, reset, check it again, and we'll just slowly narrow in on it. I think we found the setup. Good news, everybody. This is what we've been waiting for. Okay, everybody, this is the piece we've been waiting for, this little drop-down boring bar. And I like to use this offset adjustable boring bar holder when I'm doing these inside holes. And the reason I like this tool is because we have this degree wheel back here to make accurate advancements of the bit. In other words, I can set it and know what the size of the hole is going to be when I'm through. But bonehead move on my part, I had remembered this adjustable cutter as being capable of reaching a 2-inch diameter hole. We're maxed out right now, and you can see we're not even yet hitting any material. Turns out it's only 1.5 inches capable, and this hole is 1 3/4 inches right now that we're going to have to take out a little bit further. So bonehead move on my part. All that waiting we did was for nothing. So this one is entirely on me. I get myself in trouble like this on X231 from time to time. It's happened before where I'll just make assumptions and oversights, and then we end up in a bind. So because it's X231's just the lowest performing content I have on the channel, the way I choose to try to make up for that is just to try to carry more speed with the project and just churn out more episodes in a given amount of time. And the one Achilles heel of this project is that it's pretty tough to carry speed. It's almost impossible just because of how involved everything is. So I did it to myself again. Nobody to blame but me. So how do we overcome it? Well, we're gonna have to take this out. We can't use this today. I do have these fly cutters, all right? This one will fit. It uses a high-speed steel bit. I get a better finish with these carbide-tipped boring bars, but this will work. It will fit. We don't have an accurate way of positioning the bit on this setup. We just need to eyeball it, get it close, and then you bore your hole, and you have to do an inside measurement, and it is what it is when you get done. But this is something we can use and still get this job done today. It's going to involve dropping the power head on the post, which means I'm going to lose my established center, so we have to set up and recenter again so that we know we're down low enough that we have enough plunge to get that all the way through. Not the end of the world, it's just more messing around. And well, that's what I get for trying to cut corners and go fast. So one of these days you'd think I'd learn, but we're still making the same old mistakes. So bring you all back when I'm ready. I decided to bevel those leading edges a little bit to hopefully dampen the interrupted cut that we're going to have. And we're through. You can say that again. So one pass took all of the old scoring out and we've cleaned it up. But a very important step here, we need to check our work. So I've got the dial indicator set back up. We need to make sure that the setup did not move during the milling. If this still looks good and remains at 0, I can be confident that everything is where it needs to be. And I'm just finishing up with my inside bore measurements to determine what size the hole is now. I like to do several rounds of this both ways and then check my readings and just make sure everything is coming up consistent. Check this with the mic. 1.813. I've been getting that over and over again, so I'm satisfied that that's our accurate bore size. And well, you measure this original hub, it's clear that this started out as 1.750 inch and 3/4. Okay, so we went from 750 to 813, and that was just with taking enough material out just to round that. In fact, you can still feel a little bit of the material that was pushed up and is still raised a little bit right here from this old hub having wobbled around and around in there. And then you look at the outside condition of this. That's why we're oversizing this hole. We're truing it out, and we're going to make a new one of these custom sized to fit in here. So what did you do today, Squatch? Well, I drilled one hole. Really? It took you all day to drill one hole? No, I worked on it most of yesterday too, which is the truth. All right, yeah, so I want to roll this into the first of two comments that, well, they're going to help to explain where we're going here. Arthur Irwin says, I can't help but wonder how many times the engineers had to assemble and disassemble to get their final result. And Josie Smithy says, hey Squatch, was sitting here wondering if you had a video out already describing the path you plan on taking throughout this restoration. I know everything doesn't always happen in order. I'm just curious what your plan on tackling in a general order until it is finally finished. Finished with an asterisk, because it is Christine after all. Those two questions work so well with one another. That's why I wanted to include them here at the end of this episode. You look at, the multiple reworks that were done by the original engineers to the flywheel system alone on this tractor. Well, that's just part of a prototyping game. And being that we have re-prototyped several other prototype areas of this machine to try to get it in some sort of a dependable functioning state, I would say the likelihood of us having to go back into what is there to correct something, redo something, or rebuild something altogether is pretty high, to the point that I am planning on it, really. And that's why I'm not putting paint on anything until it's all back together and it has ran and operated enough that, in my mind, I'm satisfied that we've got it as good as it can possibly be. So everything here is subject to change, and we also need to accept the fact that certain parts of this tractor may still have a certain level of issues that we just have to cope with and just leave be, because at the end of the day, this was never intended to be more than just a proof of concept vehicle, and that's what we are aiming to restore it to. It's never going to be a working machine, at least under my ownership, ever again. It just needs to run and drive. So as far as the plan moving forward, or the workflow, I guess right now my next benchmark is going to be 4 wheels on the ground. So we need to finish everything with the flywheel rework so that we can put the engine on the chassis, and then we need to finish everything with the front bolster so that we can put that on the front of the engine and get front wheels down. And then at that point, it's just rear wheel hubs, rear rims, and then new tires all around. So I'm not looking past that benchmark at all at this point. And several people have asked, like, what is an estimated completion date for this job? I can't even begin to guess, because I still don't know how many problems lie ahead. That's just the nature of this machine. Everything's an absolute wild card. Even when you think you're done with something, chances are you're probably going to have to go back and revisit certain parts of it at some point. So really no estimate could even be made. So thank you everyone for watching. You kind of know what the what I'm striving for now, and we just set our sights pretty low. Don't get overwhelmed. Don't try to look past, just like I said, that next milepost that's coming up. And when we get to that, we'll make a plan from there. So hope to see y'all back again.